Question: what do airplanes, Formula 1 race car, sail ships, and turbines have in common? All four of these devices, as well as many others engineering devices, rely on optimizing wind to generate lift. Lift is basically a force caused when a fluid is acting on a solid body, causing a force perpendicular to the motion of fluid and depending on the shape of the solid body, the direction of the lift force would actually be generated. It could be an upward force or a negative force, but the direction is always perpendicular to the angle of attack of incoming air velocity. Because of this, not any solid body would actually generate lift and causing useful lift. Either it's upward, such in cases of airplanes, or downwards when we actually optimize it in Formula 1 cars to actually cause grip and handling and for corners and actually sharp turns. The airfoil shape, what's special about it is that it actually causes the most significant lift as opposed to drag force, which is the force generated by the resistance of a solid body to move because of the force being caused by incoming air velocity, which causes a lot more pressure, making it harder for an object to move through the wind. The airfoil shape optimizes its geometry by making it a teardrop. What's special about this shape is the significance lift that is generated. The lift concept, the lift force function depends on a coefficient of lift multiplied by the velocity of the density and the velocity of the incoming air, as well as the area of the actual shape itself. Okay, the coefficient of lift depends on a lot of factors, including the angle of attack of the fluid, as well as a lot of geometry, dimensions and parameters that is all calculated experimentally and found out in labs and during testings. So we haven't asked ourselves, what causes lift? Lift is actually caused when the incoming air particles on an actual shape is deflected by the solid body. The solid body is actually exerting a force on the air particles that are coming in contact with the actual body. Due to Newton's third law, when the force is exerted, the air particles are actually exerting a force on the solid body as well. This force cancels out and it generates lift. Lift can be used. The amount of lift actually exerted depends on a lot of the magnitude and directionality of the lift depends on the angle of attack, which is basically the angle between the chord length, which is the distance from the leading edge to the tailing edge with the incoming velocity. So let's say the velocity is coming in this direction, this would be our angle of attack, alpha. And cool. So how would actual engineering systems like those four actually optimize wind? In airplanes, it can be used in taking off or landing the airplane, which we could think by changing the angle of the actual foil, we can cause lift to actually. If you ever notice the wings, you'd see the flaps going up and down depending if you're taking off or landing. In sail ships, if you look at sail ships from the top view, you'd notice that it would have an airfoil shape that would actually cause the lift to allow the sail to actually sail through the seas. In turbines, The blades themselves are all actually cross sections of airfoils with specific angles and twists to generate the most amount of lift that the turbine can actually have. This force multiplied by the actual distance of a turbine would actually give you torque, and with the rotation of three different propellers, the lift force multiplied by the omega would give you power, which is how turbines operate and generate power.